Hi, welcome to our video introductory course on Basic Inferential Statistics. In this course, we are aiming to refresh your knowledge regarding basic statistic concepts that will help you further in your studies. My name is Permet Lucianova and I'm gonna guide you through today and the further videos as well. I prepared this course for you to refresh your knowledge about basic statistics, and today we are starting with probability. So our first chapter is dedicated to probability. We're gonna cover what is probability, definitions and notations. Also, we will look at multiple events, rules of probability, talk about conditional probability, very important Bayes rule, and independence of events. Each of the video will have 10 to 12 minutes long, so please take your time, repeat in any speed, and watch as many times as you want. And I hope this course is going to be helpful for you. So let's start with basic definition of probability. What is probability? So if we take simple mathematical problems, they are certain. For example, if we take 2 plus 2, we know that's always 4, right? But in real world, we often deal with the processes that are not certain and are random. For example, coin toss. So basic coin has two sides. It has head and it has tail. Coin has two sides, head and tail, and we cannot certainly predict which side we're gonna get. This process is called unpredictable or random. And in statistics, it's defined as random experiment. So a random experiment needs to meet the following requirements. We need to know the possible outcome of experiment. In our case, it's either head or the tail. And the second requirement is that outcome of the concrete experiment is not known. And we assume that we can repeat the experiment as often as we wish. In other words, we know that we're gonna get head or tail, and every time we toss a coin, we know that we're gonna get either of them, but we don't know exactly which of these two possibilities we will have. So the possible outcome of the random experiment is noted as lowercase omega, or we call it O, and united in big omega as set of all possible outcomes, like here. So in our case, head will be O1 and tail will be O2. And these two omegas will be basically our set of all possible outcomes. So this is outcome 1 and this is outcome 2. So now we came up to the main question: what is the probability of getting head after tossing a coin? We know that we're gonna get either head or the tail in this case, so we have 50% of a chance to getting a head. So basically, the probability is telling us how likely is the desired outcome to occur. In our example, our desired outcome is head. And we have only one head, and our sample set omega had two elements, head and tails. Thus, the probability is equal to 1/2 or 50%. So let's have a look to another example, which is throwing a dice. As you remember, the dice has 6 sides, and each side represents a certain number, starting from 1 to 6. In this case, we are increasing our omega set to 6 elements. And let's say we want to get 1. So the probability of getting 1 is again the number of desired outcomes divided by total possible outcomes. So our desired outcome is 1 and we have only one side that represents 1, and in this example we have total of 6 possible outcomes. So probability to getting number 1 while throwing a dice is equal to 1/6. Let's ask the different question. For example, what is probability of getting an even number? If you remember, even numbers are divisible by 2. In our sample set, we have 3 desired outcomes. So our even numbers will be 2, 4, and 6. So to answer this question, we want to get one of these 3 numbers, 2, 4, or 6. If we're getting one of them, it's already good. So in this case, we have 3 desired numbers, and the total of possible outcomes stays the same. It's the 6. So for this example, it's going to be 3, 6, or 1/2. Every subset of omega is called event. So for example, throwing dice and getting 1 is event, and throwing dice and getting even number are both events. Since 1 has only one outcome, it's called elementary event or singleton. To make notation easier, any event is denoted by letter A. If we have several of them, like here in example, we name the second event with the letter B, so we're not get confused. So the probability of event A always lies somewhere between 0 and 1. 1 being 100% certain and 0 being impossible. Like for instance, getting 90 when throwing 1 dice is just impossible. If we want to picture our set of all outcomes omega, we can say it's like this is omega, and it has small omegas here. And each of this outcome could also have different probability, like 0.05, or this being impossible and this having probability of 0.25. Each of possible outcome can have different probability. If you look at here at this picture, we can see that if event is certain, probability is equal to 1. For example, we can say event getting any number larger than 0 while throwing a dice. So when throwing a dice, we can say for 100% that we are fulfilling this event. This event is certain. No matter how many times we're going to throw a dice, we're going to get a number which is larger than 0. Also, to find probability of a certain event, we need to sum all the probabilities of outcomes which are found in A. And the second thing that we have to mention that all the small omegas in big omega, they are non-negative, because the probability of event could be 0 and could be 1 if it's 100% certain or impossible, and lie somewhere in between, but it's non-negative. And the third important thing here to mention that to find the probability of event, we need to sum all the probabilities of its outcomes that we found in A. So let me write it here. So if we have a probability of event A, which let's say is getting an even number, so it's going to be sum, this is a sum sign, sum of all small omegas that could be found in event. In other words, so we have here 3 numbers. We have to sum up all the probabilities, probability of getting 2, probability of getting 4, and probability of getting 6 in order to find probability of A. So what we do, we find each individual probabilities. As we saw in the previous example, getting probability of any single individual number was equal to 1/6. So we just add 1/6 3 times to each other and we get 3/6. It was the same answer we got on the previous slide, but this is how it's combined. So, and we can say that sum of all probabilities cannot exceed 1. Let's move on to the next topic. I hope everything is clear here so we can move further.